All right. So yesterday we started section 2.1. Okay, that was on how we measure an angle. Talked about degrees and radians and how we convert between the two. Okay, we're going to talk about two things today. One thing we're going to talk about is how do you measure the length of an arc? Okay, we can't just use the distance formula to do that. Why not? The distance formula only works for what kinds of things? Doesn't work for this kind of thing. Yeah. Yeah, it works for straight segments. Okay, you can't use the distance formula on an arc. Okay, but that thing in red is called an arc. So that's the first formula we're going to look at. How do we find the length of an arc? Next thing we're going to do is look at how we find the area of that region. Okay, we're going to try to find the area of that region in green. Now, why can't I just use the formula for the area of a triangle? It almost looks like a triangle. What's wrong with it? Yeah. Yeah, the third side is curved. It's an arc. So that's not a polygon. It's not a triangle. This shape is called a sector. Sector. Kind of think of like a piece of pizza, right? Piece of pizza, that's a sector. It's got one curved edge, and it's got the two straight ones on the sides. Right, so we'll look at those two formulas. Normally what I do is I go through and prove where the two formulas come from. But for the purpose of what we're doing, I think what we'll do is I'll give you the formula, and we'll just practice using it. Okay? Because on a test, I generally don't have you derive formulas and prove them. I do that part in class, and all you have to do on the test is apply the formula. Plug in the numbers and do the result. So let's just practice that. Okay, so the first formula, this is the arc length formula. That's it. That's the whole formula. S equals R times, that's a Greek letter. Anybody know what Greek letter that is? It's theta. 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 In trigonometry, a lot of times when we don't know an angle, that's the variable they use to represent it. It's just like in Algebra 1, you use x a lot, or you use y. Well, we use theta. It's just a letter. Okay? And as I just said, theta is used to represent an angle. Okay, what's important about the angle is it has to be in radians. This formula doesn't work if the angle's not in radians. So if you've got degrees, your first step is to change to radians. Okay, S, that's the arc length. And what do you think R is, having to do with a circle? It's the radius. Okay, the arc depends on two things. It depends on how big of a circle do you have, and it also depends on how big of an angle do you have. Change either one of those things and you change the size of the arc. Okay, the way this formula works is they're going to give you 2 out of 3 variables. They'll either give you the R and the theta and have you find S, or they'll give you the S and the R and have you find theta, or some combination of the two. Okay, but you'll always be given 2 out of 3 of the letters. Let's try an example. Okay, so the first example, I wrote it out. So suppose we have a circle, and we have an angle inside of pi over 3. Radians, that's my angle. The radius is 4 inches. They want us to find the length of the arc. Okay. This is the arc they're talking about. It's where the 2 rays of the angle hit the circumference of the circle. We're finding the distance between those 2 points. Okay, so the first thing I like to do is write down my formula so I can see what my formula is. And then I'll plug in what they give me to the formula. Okay, let's take a look at the 4. Okay. Where's the 4 going to go in that formula? For what letter? Yeah, that's the R, radius of 4. Okay, it says I have an angle of pi over 3. Where's that going to go? Theta. Okay. Is it in the units I want, or do I need to convert it? It's good. It's fine. It's already in radians. We don't want to change it. And find the length of the arc. That's what I don't know. That's what I'm finding. So just leave that as S. Okay, unless they ask me for a decimal, you do not need to find a decimal. Okay, so we're just going to multiply this out. If you want to think of that as a fraction, you can put it over 1. You're going to get 4 times pi divided by 1 times 3. That's it. That's the answer, 4 pi over 3. Now, we just found the length of an arc. How were my lengths measured in this problem? What were the units they used? Inches. If you're finding an angle, the unit is always radians. But if you're finding a length, which we just did, the length of the arc could be inches, could be feet, centimeters. Go back and look at the problem and see what they used. Okay, any question on that? Right, if they want the decimal, all you got to do is type in 4 times pi divided by 3. Whoops. 4 times pi. It's about 4.2 inches if you round it up. Okay, but don't worry about rounding it off, because we're not gonna plug it in. We'll just leave it like that. All right, let's look at this one. Okay, same type of problem. This time I just drew a diagram rather than writing the whole thing out. Find the length of the arc. So I got my formula. S equals R theta. Anybody see anything here I want to be careful with? Yeah, the degrees. If you forget to deal with that, the whole thing is wrong. Okay? What do I have to do with 130 degrees? Yep, and that's going to change it to radians. Good. Okay, so degrees cancels out. What I'll do also, divide top and bottom by 10. That's as much as I can reduce it. It's 13 times pi over 18. Leave it just like that, 13 pi over 18. So I'll fill that in. 13 pi over 18. What about r? What's my radius in this one? 8. How could I make it a fraction if I wanted to make just like the other one? Put it over 1. And now when I multiply together, what number goes into both 8 and 18? 2. Yeah, good job. So that becomes 4. That becomes 9. Okay, so my final answer, 4 times 13, it's 52. Don't forget the pi, divided by 9. And that's it. You don't have to do that out. Now again, let's look back at what we found. We found a length. What were my lengths in this problem? Feet. So it's 52 pi over 9 feet. Yes?
If the numerator and the denominator were divisible, could you simplify it?
Yeah, if I could reduce that more, I would. But in this case, I can't. Yep. I did my reducing up front by 2. Okay, any questions on that? So both of those were finding the length of an arc. This one now they want you to find an angle. Okay, what's the pi over 4? What letter does that get plugged in for? Yeah. We have an arc length, pi over 4. Fill that in for S. We have a radius of 12. So fill in 12 for the radius. Find the angle. That's what I don't know. Okay, so my last step is to get the 12 on the other side. Okay, how would I move 12 to the other side? Yeah, divide it by 12. Dividing by 12 is basically the same as just putting a times 12 in the bottom of that fraction. I didn't want to write it like this because I thought that would just confuse more people if you divide by 12. Some people like to think of it when they have a fraction over a fraction as you flip and multiply by the reciprocal, and that puts the 12 right in the bottom next to the 4 anyway. Okay, so that's just a little shortcut to divide by 12. And what's 12 times 4? 48. And what is pi over 48? Is that my arc length, my radius, or my angle? That's my angle. So do I need to write a label?
Or we, no.
It's in radians, but do I have to write RAD? No. It's always understood to be radians. You don't need to put the label. Okay, so there's an example where you're finding the angle. And the last example we'll do where you're finding the radius. Okay, again, what do you want to be careful of here? Something really simple, but it could mess you up. Yeah, your angle is in degrees. Okay, so I'm just going to convert this for you. It's pi over 5. If you multiply by pi and divide by 180, you'll see that's what it comes out to. It's pi over 5. Okay, what about the 13? What's that in this problem? That's S. Radius, I don't know. Angle, it's 36 degrees, but we're going to convert it. We already did. Pi over 5. Now, anybody remember how you can get the pi and the 5 on the same, at the same time on the other side? Yeah, multiply by the reciprocal. What that's going to do is get rid of the 5s and the pi's at the same time, leaving r by itself. Okay, so then we got to do 5 times 13, which is how much? 65. What goes in the bottom? Pi. And now we just found a radius. That's a length. That's not an angle, that's a length. What were my lengths in this problem? Feet. Okay, so there's one of each type for finding the length of an arc. Any questions before we move on to area, which is it's pretty much the same difficulty as length of an arc? Any questions on that? All right. So again, what I normally do is I go through, explain where the formula comes from. For the sake of time, I'm going to just show what the formula is. So this is the formula for area of a sector. All right, so area of a sector is 1/2 r squared times theta. Okay, let's just label each letter, make sure we know what they all are. Again, theta, what do you think that is? That's my angle. Anything special about it? It's got to be in radians again. Don't use degrees, it won't work. Okay, r is going to be my radius. Now, we didn't have an a in the last formula, but what do you think a is? Area. Okay, same kind of deal with this formula. They'll give you 2 out of 3 of the letters. You plug them in and find the third one. So it's really no more complicated than Algebra 1. The more complicated part is proving where this formula comes from, but again, I'm holding off on that for today. Okay, does everybody have that formula? So A equals 1/2 times the radius squared times theta. Okay, so find the area. Okay, first thing I'll just write down our formula. What's my radius in this problem? Yep, 4 centimeters. Some people like to square it and take half of it all in their head. I'm going to just show out each step so nobody thinks I'm skipping anything. And what about my angle? Pi over 6. Do I have to do anything with it? Nope, it's good to go. It's already in radians. Okay, 4 squared gives me, how much? 16? Yep. And now half of 16 is 8 times pi over 6. If you want to make 8 a fraction, you can. Any number that goes into both 8 and 6? 2. So that becomes 4, 3. What am I left with for my final answer? Good, 4 pi over 3. Now that's an area. I just want you to think for a second about what the label would be. Centimeters squared, right? Okay, so any question on the type of problem where you're given R, you're given theta, you find A. That's one type. Okay, I'm not going to do another one of that type. Let's move on to the second type. Somebody tell me, just to make sure we know that, what's my formula that I'm going to use? 1/2 r squared theta, good. This time they're going to give me the area, they're going to give me the angle, they want me to find the radius. Something I want to do before I even start this problem. What's the first thing I should do? I'm going to change degrees to radians. Okay, if you do it, trust me, that's what you'll get. Multiply by pi, divide by 180. I'm going to get pi over 4. What's this 8 pi over 3? Yeah, I know it's the area because look at the label. It's square inches. Anything with units of square or 2, it's got to be an area. So 8 pi over 3 equals 1/2. I don't know r, but I do know theta is pi over 4. Okay, and there's a few options here. You could try to combine this 1/2 and pi over 4 together. Or we can just start moving things one at a time to the other side. Let's do it that way. Let's start with pi over 4. Okay, remember, this is all multiplied together. How could I get the pi and the 4 on the other side? Yep, multiply by the reciprocal. 4 over pi. Pi's are gone, 4's are gone. 8 times 4 gives me how much? Yep. 8 times 4 gives me 32. Now, what's going to happen with the pi? It's going to go where? Yeah, it's going to cancel out. Got a pi in the bottom, pi in the top. So we're left with 32 divided by 3. All right, so we got 8 times 4 is 32 divided by 3. And then on the other side, we've got 1/2 r squared. 2 more things we got to get rid of. The exponent and the 1/2. Which one do you do first? The 1/2. Yeah. What could I multiply each side by to cancel out 1/2? 2. Let's put it over here. Multiply by 2. multiplied by 2. 2 times a half is 1. That's gone. If you want to think of 2 as a fraction, do it like that. What's 2 times 32? 64 over 3. And now we're down to our last step. How do you undo squaring something? Take the square root. When you take the square root of a fraction, you do the top and you do the bottom separate. Okay, so we're done the trig part. Now it's just a little arithmetic to clean this up and make it look a little nicer. Square root of 64, can I do that out? Yeah, we get 8. We talked about this earlier. What's wrong with that? It's got a square root in the denominator. What do you multiply by to fix that? Square root of 3? Yep. Over square root of 3. So now for my final answer, I get 8 square root 3. And the square root of 3 times the square root of 3. That's the square root of 9, or 3. Okay, leave a little space to write your units in. Radius is a length, not an area. That's a length. So I got to go back up and look at my lengths. Inches. Okay, I think that's the hardest type because you got to deal with the square root. Okay, last thing, I'm going to skip over this one where you find the angle. We did that with arc length. I'm going to give you a hint for a problem on the homework. Okay, on the homework, they give you a problem that has a clock. Okay, they draw in a minute hand. And they basically ask you how far the tip of the minute hand is going to move from 12 to 5. What shape does the tip of the minute hand trace out? That's an arc. Okay, the tip of the minute hand is tracing out part of a circle. That's an arc. Okay, they're going to tell you maybe something like the minute hand is 6 inches long. 6 inches is like your what? Radius. That's the radius. It's the length of the hand from the center to the edge. The last part we need is the angle. Well, we got to figure out the angle between 12 and 5. Luckily, though, on a clock, everything is evenly spaced. Let me give you a hint. What's the angle between 12 and 3? 90. So how much is each section from 12 to 1, 1 to 2, and 2 to 3? 30. Each section is 30, 30, 30. That's how you get a 90. So what would be the angle to the 5? 180 would be halfway around. 150. Yeah, it'd be 150. Okay? So that's a hint from a problem in the homework. Another one they talk about is a pendulum swinging. They tell you got a pendulum, maybe 40 inches long. As it swings back and forth, what's that shape? Arc. Another arc. They ask you how far the pendulum swings on an arc. And the length of the pendulum is like your radius. Right, so a couple hints for the homework. Okay, so the homework is on page 99. 71 to 87, just the odds. And 91 to 94, all. Okay, what I'm also going to do, I'm going to go back and show the one example that we skipped over. So if you're watching this and you want to see that example we didn't do, I'm going to do that right now. All right, so the last one was finding the angle when they give you the area and the radius. So start out with the formula. Fill in what you know. A is pi over 2 equals 1/2. This time the radius is 3. I'm going to square it times theta, which is the angle we don't know. Okay, first thing I'm going to do is do 3 squared, which gives me 9, and then take half of it. Simple way to do that, just leave it as a fraction. 9 over 2 times theta. And now my last step, I'm going to move 9 halves to the other side by multiplying by the reciprocal, which is 2 ninths. So 9s cancel out, 2s cancel out. You're left with theta on the right-hand side. 2's also cancel out right there. You're left with pi over 9. Again, no need to put a label on that because it's in radians, and we don't have to write RAD. Okay? So there's example 7, the one we didn't get to.